Now example 1.8 asks us to find the composition f of g of x and the composition g of f of x given the two functions, f being 3x plus 1. Actually, that's the opposite of my color code before. So f is 3x plus 1 and g is x squared minus 1. So first let's find f of g of x. I'm going to try and keep my color coding here. So we have f of, and then g of x is in blue, g of x. So that's going to be equal to f of, and then g of x is x squared minus 1. So first I'll plug in x squared minus 1, and then f is 3. So f takes 3 times whatever the input is and adds 1 to it. So in this case, it's going to take 3 times x squared minus 1 and add 1 to it. So when I evaluate that or simplify this, I get 3x squared minus 3 plus 1, or 3x squared minus 2. Now if I want to find g of f of x, then first I'm going to evaluate f and then stick that output into g. So since f of x is 3x plus 1, I'm going to have g of 3x plus 1 and g is x squared minus 1. So that says you take whatever the input x is, you square it, and you subtract 1. So in this case, I'm going to get something squared minus 1. And that something squared is 3x plus 1. Okay, so when I work this out, I get 3x squared plus 1. When I square that, I get 9x squared plus 6x plus 1, and then minus 1. So that should be 9x squared plus 6x. And so now you can see here that in general, f of g of x is not going to equal g of f of x. And that's just because order of operations matters in algebra here. So if you evaluate g and then feed that to f, that's different than evaluating f and then sticking that into g.